Thanks. Sorry I'm late. I've been sick the last 2 days. I only got 2 hours of sleep last night, and I'm heavily medicated. So please bear with me. I'm going to do the best I can. All right, so birth and evolution of AsyncHooks. This is a new API that will be in version 8 of Node. We're not going to be backporting it for various reasons. But hopefully you all can enjoy it, and I hope by the end of this you all can understand why the API is as it is today. So first off, this all began thanks to Forrest. He opened a pull request for a new core module he wanted to do called continuation local storage. And what it did basically is a type of like a thread storage, except it would work with asynchronous requests. He worked at New Relic at the time, and yeah, they needed to propagate data between asynchronous requests so they could track all those lovely metrics that they track. So when I saw that, I just felt like it was way too specific. It didn't cover, I saw into it more general concepts than just the one ability to propagate data across asynchronous calls. And so at that time, the module was called AsyncListener, and I began to work on it, and the very first implementation took just a month to do. It changed ridiculously as time went on, but that first implementation was just put in because people were needing it for various things. There were 2 design goals when I started out. One was to incur no overhead when it wasn't running. And that might sound funny, like, well, you're not using it, why would it incur overhead? Well, as we'll see in a little while, this whole mechanism is tied directly into all of the, well, everything, really. If you do anything asynchronous in Node, you are using this, you are touching this. And so I wanted to make sure that if it wasn't being used, all the extra state and other internals that it had to track wouldn't cause any performance degradation. And I wanted to make sure, while there was no way to perfectly answer this question, once I started out, I had Forrest's use case, but then I reached out and asked other developers, if you had this type of feature, what would you want to be able, what would you want to be able to do with it? And they gave me a list of things that they all would have liked to do using this API. And so I took those and compiled them and found similarities between them, and I tried, at the beginning, I tried to develop an API that would address all those concerns. Yeah, that first landed in September of 2013. Actually, we're going to be hitting the anniversary of that, the 5-year anniversary. Wait, 4-year anniversary, and on the 26th. So, yay! Yeah, sometimes I wonder why I volunteered to do that, and I just wish that I had left it alone completely, because this has been haunting me since the day it landed. So, from the very beginning with AsyncListener, there was a C++ class called AsyncWrap. And the AsyncListener was the JavaScript API that developers would use to make my screen go away. What just happened? It will. Cool. Sweet. All right. So needed to create a C++ class that would centralize all of these asynchronous calls, because at the time, you had TCP, UDP, crypto, even the process of processing headers for HTTP requests, and pretty much everything in Node, right? All of it was asynchronous, but it was, every single class was its own siloed thing. And so if I were to do this, I either had to go out and like add the same code to all like 18 classes, I think, or I could refactor it, add one class that all of them inherit from, and then have it be a central location where they can, where I can begin to collect those metrics. Yep. And it's inherited everywhere by everything all the time. It's really a pain, actually. Kind of a pain because we have some classes, get this, we have some classes that are template with multi-inheritance that need to do parent-to-child casting, and that gets fun. We actually had, it was an obscure bug, but you cast it incorrectly, and then you call a function, and then that would just return you a random memory address with random bits. Oh yeah, that was good. So coming back to the user API. So the first supported events were on initialization, like when you first created the asynchronous resource. And I say resource because that encapsulates what we know as handles and requests. A handle would be like a TCP server, because that's defined by the fact that it can fire a callback multiple times. Like every single time it receives a connection, it will fire the on-connection callback. And a request is something that happens once, like you read data from a file, right? You ask it to read data, it returns you the data, and then it dies. Like there's nothing else to do. So I see a resource encapsulating those two ideas. So on initialization of any of those resources, and then you would get a call before and after the callback was going to be executed. And then at that time, it actually had unhandled, it handled unhandled exceptions from the callbacks. We'll get into this later, but that was the bane of my existence for like 3 months. So yeah, you could handle exceptions, and they'd bubble up through all the callbacks you had and whatnot. That the exception handling was removed, and it died a horrible death, as it should have. At that time, the domain module was re-implemented using AsyncListener, which was great because the domain code is intrusive, and it's like a parasite that is throughout core, and it just has to execute everywhere all the time, and it's just really ugly. So at the time, I rewrote domain to use AsyncListener instead, and then also I provided, I had provider filtering. A provider is like the type of class, the type of resource that is instantiating, like a TCP resource or a UDP resource or a file system resource, right? And so you could say, filter my resources. I only want to know about TCP and UDP. Don't give me anything else, right? And so that it would check those, and it would skip everything that wasn't those. So, continuing with AsyncListener, this is, I really miss this feature. It was one of my favorites. But it had the ability to track individual paths. So say you were to enable an async listener and you're to perform an operation. So like say A there is an on-connection event for a TCP server, right? So on A, you say, I want to begin tracking everything this client's doing, right? And so let's say B is grabbing some resources from server, C is writing to the file system. Now C, you see the dotted. What happens is like C comes back, and then the logic will branch, right? It's like if it succeeded, go this way. If it failed, go this way. And so say if it failed, I can disable the async resource on like that individual resource, but it would only disable it for that path, which means the async resource you enabled would still execute for all other paths that you had. I have no idea if I'm explaining this well. It's really abstract, and I remember discussing this in bugs in the issue tracker, and it was horrible. So yeah, those dotted lines. But then, if say in F something happened and you recovered from the error, you could say, okay, begin tracking me again, and so you could resume tracking. And so you could choose what, say, you were to draw a tree of all your asynchronous requests happening, and you say, I want this one, and I want this one, but I don't want this one, and I don't want this one, then it would execute your callbacks, your hooks, based on what you enabled or disabled, which was great when you wanted to save resources and disable some of those. By disabling the callbacks, you could save execution time. And also, people don't believe me. Well, not that they don't believe me, but it's hard for them to understand. If you're running like a really hammered TCP server where you're sending out a lot of small packets, like say each of those letters is an asynchronous event. If you're running a TCP server that's getting hammered, you can do 1 million of those a second. And like that's not an exaggeration. You can do 1 million asynchronous events per second on a really hammered server. Mapping that is impossible, right? And so I wanted to provide a way for people to bring down the number of paths that they were recording so that it became more manageable, because mapping out 1 million, like, yeah, we've had people try various ways of doing that, and they have all failed. If anything else, it's impossible to process those things in real time so that you can like graph it for your metrics. If anything, you have to like store everything and then process it later because it's just way too much data. Okay, and then it all died. Okay, so let's see. It first landed in September of 2013, right? And then it got removed in December of 2014. So a year and a few months of work just got hacked and dropped and kicked. And the first thing was removing the domain implementation, because domains attach to the event emitter, and by doing that, it made it impossible to fully replace it with the AsyncListener API. There were other edge cases that were really difficult to handle, and at the time, TJ just said before 0.12 goes out, and if anybody remembers like how crazy long it was between 0.10 and 0.12, I don't remember, it felt like an eternity, right? And so he basically said like, okay, we're cutting it. We can't have any more delays, even though we've delayed, for forever. And so prior to that, in November, about a month before it got removed, I created an API that hooked directly into the native API as a set of hooks, so developers could play with it and try and come up with a better JavaScript API. And that way we could also tune the C++ API so that it would become more flexible. Okay, so between when AsyncListener was removed and the introduction of AsyncHooks, there were only 55 commits on async wrap, but all of those were like really well thought out, very intentional commits. I cannot express to you how difficult it's been to create an API that touches basically everything that affects nothing in a negative way. And so everything has been meticulous and well tested. And so one of the things, it was super simple. Each one was assigned a numeric ID. Now, really, this sounds super basic, but it allowed us to do some really cool stuff. And it wasn't so much the fact we introduced the unique ID, it's how we figured out how to use it afterwards. We'll get to that. And then we also began to, so say for example, you do a set timeout, you have a timer, inside you're doing a file system request, right? And on the file system request, you're going to have the init call saying, hey, I'm about to do a file system request. What we got it to do was in the init callback, it would hand it the parent that called, like the parent object that called it. So that you could actually set up a chain, like a full chain, execution chain of these things. And what was nice is you could actually inspect state while the application was in motion. So we had some modules that they could point to a certain branch in the asynchronous execution and say, follow this. And then they would show all the objects and all the values on those objects changing in real time as everything was occurring, and it was great for debugging. Now the providers, if you remember, I said they're like TCP, UDP, whatnot. I hooked those in to the V8 API so that they would be tracked by the heap dump. Prior to that, all of the C++ classes were not tracked in heap dump. So if you took a heap dump, you wouldn't see the allocation for all the C++ classes. And so, you know, you'd have your unknown or native, you know, like whatever that memory counts for, it just wouldn't show up because of that. So I hooked into the V8 API. I was able to use the providers so that all of that is now tracked in the heap dumps. And that's useful because by clicking on the C++ class instead of the JavaScript class, you're able to get a better idea of the branching of object relations. And then I finally figured out how to support the destroy event. So the destroy event is basically when a class gets deleted or like when a timer is done and it's not going to execute anymore. That will execute a hook called destroy, and so you can know, like, when you can clean up your map of resource. Like, say you have taking the unique numeric IDs, say you're creating a map, and you say, okay, here's this TCP resource, its ID is 2. We're going to track it, and then once the server closes or whatever, it's going to call the destroy hook, and then you can use that to delete the value in the map so that you can keep your resource usage down and only keep resources in there that are alive so that your scripts can run longer and not consume as much memory. That took a ridiculously long time to get right, and it still has one caveat, which is if like there are a lot of things like timers and TCP handles that are explicitly destroyed, like when you run close on a server. But also there are resources where they're garbage collected, and so if you keep a reference to that, it can never call destroy because you're preventing the garbage collector from collecting it. So, yep. And then my first commit for AsyncHooks was in February of 2016, and then the PR was open in September of 2016. So it's just slight lag there, again because before we even hit the PR stage, there's a lot. I was working with other developers behind the scenes to spruce it up, and then from September 2016. It finally landed in core in March of 2017. So, yeah, that is how we finally got to AsyncHooks. over that long, long period. So it took a really long time. One reason was people really didn't want to review a patch that big. I mean, like, they jump into it and they just fizzle out. Like, they get 2 or 3 files in and just be like, oh, okay, I'm done, right? And I can totally understand that. Also, because people would jump in, and I mean, when you're reading code that affects all other code, it takes a heck of a long time to create the mental model of what's happening. And so, I mean, in comparison to this PR, to other PRs, I'd say like this one was actually 5 times as long because of the amount of work you needed to put in to understand it. So yeah, it took a long time to get properly reviewed and to finally land. And oh yeah, so oh man, it's been one heck of a ride. So yeah, it truly sits at the center of everything asynchronous, and Node is the center of everything asynchronous. So yeah. Oh man. Okay, so the API, the differences between the AsyncListener API and AsyncHooks API was that the exception handling was removed. We'll get into that later. The deconstruction hook was added. The ability to trace each async path was removed because the feature of being able to AsyncListener was a single global handler. Like, if you registered something, you would erase what somebody else registered, right? So it was a single thing. And people wanted, now the reason I had done that at the time was because I wanted module authors to try things out, to try out writing a module that allows many people to hook into that API. Right? I wanted to see what they were going to do, so I was forcing that on them so that I could see their work. In the end, people, developers, voted for having multiple listeners, right? Multiple instances, and then each one can be enabled and disabled. The kicker is that each one can be enabled and disabled globally, right? So I would have been able to keep, the branching if the feature of disabling everything globally hadn't been added. But the only way to have done both would have been to keep a map of all active hooks, and that every time a hook was to run, it would take its own ID and compare it to the list of IDs that were active and see whether it should run or not. And it was just an insane amount of, huge performance hit. We just couldn't get there. Filtering on provider was out. Other developers decided that people couldn't do that themselves. So object tracking was then done by unique ID. Instead of, before it would just hand you, like, say a TCP server started, it would hand you the TCP server and say, use this to track everything. Instead, we switched over to a numeric ID, and that turned out to be a whole lot faster. And that way you could say, okay, this resource is this type, here's its ID, we'll track everything on that ID. The parent, I think I discussed this before, propagated, introduced the idea of trigger async ID. We'll get to that in a second. And I'm sure a lot of people will be happy, but it now has full promise integration, which that took a heck of a long time, not only for myself, but a bunch of people at the V8 team. They did a lot of work creating an API. I mean, the V8 team created an API just for us, so that we could get async hooks to work with promises. So the asynchronous events, init, before, after, and destroy, already talked about those. A new one, which is actually sitting in a PR, and is about to land is called promise resolve. And I'll have an example later so it makes better sense. But it tells you when the resolver in a promise constructor fires. Yep. Okay, so why wasn't it removed? Because it was horrible. It was a super bad thing. Really, really horrible, horrible thing. So once we allowed multiple hooks to stack, what had to happen with this async exception handling was that it would bubble. And so in each exception handler, you would return true if it was handled. And if it was handled, then it'd kick off and it wouldn't call the rest of the hooks above it, or the rest of the listeners that were sitting in the stack above it. If it didn't, then it would jump to the next one. But the problem is that this one doesn't know if this one cleaned up properly. But if this one returns true, and this one did jack squat, suddenly your application is in an unknown state and things blow up, right? So yeah, that will never go in. And unfortunately, there are people talking about wanting to put this in the new zones API, and I am vehemently against that because I have spent months, literally months, when I was at Mozilla, all I did was program Node, and I put in at least 200 hours of just doing this, and it was horrible, and it should never happen again. So, execution ID. How much? Okay. So execution ID is where the ID of the current execution scope, and then the trigger ID is more abstract. It's the ID of the resource responsible for the call. So right here, right, with execution and trigger ID. So create a server, now we have the listen event, right? Now on the listen event, if you don't pass a port, it just uses your local host. So technically, if it doesn't have to resolve a host name, the call is actually synchronous. But what it does is it throws the listen callback into a next tick so that it can be called in the future. So then if we, so jump past that, look at the bottom, we have execution async ID and trigger async ID. That's 1 and 0. That's your base for like your bootstrap. And now inside here, you have the async ID of the server, which is 5. Now the execution async ID is 6. That's of the next tick. And so that output, like that information is actually useless because I don't care anything. I don't care about that next tick. If I trace the tree back, it's listen callback, next tick, bootstrap. I know nothing about the server, which is stupid because I'm listening to the server. And so the trigger async ID is meant to pass on that information. It lets you know what, what resource is responsible for another resource's init callback to be called. And so yeah, the AsyncResource has a JavaScript API and has a static API. Yes, we recommend you use the AsyncResource JavaScript API because it's less of a pain in the butt, and you're less likely. So while everything's executing, it keeps track of the asynchronous stack. If you corrupt that stack, it will abort on your face. It doesn't care, right? If that thing goes bad, Node has no idea what's going on. Nothing should ever be able to do that. And so right now, my code forces it to die because if that happens, there is no way to recover because you've lost all hope. So, promise integration, you have the normals, so like new promise would trigger init, and then like the callback and the then would trigger the before and after. But now the reason the new promise resolver hook is important because see this new promise constructor, you have those set timeouts, and one, like you don't know which one will call the resolve, right? You don't know. And the init, before, after, and destroy, you don't get that information from any of those. And so the promise resolver will fire whenever that resolver callback is fired, so you can track the code path when the resolve is called, and that has made it so much more useful. I personally don't like promises, but this is an amazing feature added that will be added soon, and it will be put into V8, version 8. Okay, C++ API. We also added a C++ API, and there's also a runtime agnostic API in NAPI so that other VMs like Chakra can also implement this. So this API will work across the board on all VMs that implement it. Miscellaneous bits, and this is the very last slide. So the async ID, when it was first put in, it was an int64, which made a lot of sense to me. But then I came to the realization that that's pointless because everything in JavaScript is a double. So I changed it to a double, and a lot of people were like, whoa, that's not smart because it's a double, and you don't have like the 2 to the 64. And then I showed them like, okay, well, 2 to the 53 minus 1 gives you 28 years of resource allocations if you allocate once every 100 nanoseconds. And Node can't allocate once every 100 nanoseconds. So you're guaranteed to last at least 28 years. If your process has run for 28 years, I will give you $1 million. And then this keeps track of an insane amount of state, a ridiculous amount of state. And so back in 2013, I developed a method of sharing state between JavaScript and C++ by creating a typed array. So like I would create, that doesn't matter, that's the last slide. It would create like a struct in C++, and then a typed array would wrap that. And then you could write to it from C++ or JavaScript, and then you'd instantaneously communicate that state back and forth instead of needing to go through the VM. And that is main reason why this is possible, because if we had to go through the VM every time we needed to communicate that state, the performance hit would be so enormous that that it wouldn't even be close to possible. So I'm very proud of that by myself. Like, I feel like that's my one contribution to Node that I'm really proud of. I'm not proud of AsyncHooks. It just has happened, and then it stuck with me like a leech. So that's it. Thank you. Crap, did I go over? I went over.